Good afternoon, everyone. My name is Jheelam Mondal. I am Assistant Professor in CSE Department of HIT College. Today, I am going to discuss about naive-Bayes classifier, which is a interesting topic in a machine learning subject. So, what is naive-Bayes classifier? Before that, starting with the working principle, I am going to tell that naive-Bayes classifier is a supervised learning algorithm and which is based on Bayes theorem, and it is used for solving classification problems. So what is classification problem? Hope you remember. Classification problems are those problems where inside the dataset we have the target outcome belonging to separate categories or classes. So here Bayes algorithm is applied on classification sort of problems. Coming to the application area, as it is mentioned, it is mainly used in text classification areas that includes high dimensional training datasets. So what do you mean by high dimensional training dataset? High dimensional meaning it contains more than one or more number of features inside the training dataset. Naive-Bayes classifier is one of the simple and most effective classification algorithm which helps in building the fast machine learning models that can make quick predictions. Also, it is called a probabilistic classifier, which means it predicts on the basis of the probability of any object. Why the term naive-Bayes is there? As you can see, it consists of two words, naive and Bayes. Naive, it is called naive because it assumes that the occurrence of a certain feature is independent of the occurrence of any other features. And Bayes because it is applied, because it is based on the Bayes theorem. So it is also called naive-Bayes theorem. Some popular other examples of naive-Bayes algorithm are spam filtration, sentimental analysis, and classification of articles. So now let us see what is Bayes theorem. So Bayes theorem is also called Bayes rule or Bayes law, which is used to determine the probability of a hypothesis with some prior knowledge to it. It depends on the conditional probability, and as you can see, the formula of the Bayes theorem is given like P of event A given event B is equal to P of event B given A multiplied by P of A, and it is divided by P of B, where we have to assume that P of B should not be 0. So what does those individual terms mean in terms of the machine learning model? So P of A given B is posterior probability, and it is the probability of the hypothesis A after the event B or the evidence has observed or occurred. So P of B given A is also called likelihood probability, and it is the probability of the evidence given that the probability of the hypothesis is true. P of A is also called prior probability, probability of hypothesis before observing the evidence, and P of B is also called marginal probability, which is the probability of the evidence. Okay, so what are the basic steps to apply the naive-Bayes classifier? So to solve this kind of problems, we need to follow the below steps. Number one being conversion the given dataset into the frequency tables. Number two is generate likelihood table by finding the probabilities of the given features. And number three is now use the Bayes theorem or apply the Bayes theorem to calculate the posterior probability. So let us see with some real life data set how it works. Suppose we have a data set of weather conditions and corresponding target variable play is present. So using this data set we need to decide that whether we should play or not on a particular day according to the weather conditions. Here the problem statement is if the weather condition is sunny then the player should play or not. This is the problem, and the solution to this is we have to apply the naive-Bayes theorem on top of it. So how do we apply the steps? First we need to look into the data set. As you can see, the data set consists of 14 records because it's starting from 0 and ending at 13 serial number, and you have two columns, outlook and play. So outlook is nothing but the weather condition. So this is a feature, and the play is the outcome of the target variable where it is either having value yes or no. So this is a binary classification problem. And as you can also observe clearly here that there are only three distinct values in the outlook column, which is rainy, sunny and overcast. So these are the three distinct values present for the weather condition. Now my first job is to convert this entire data set into the frequency distribution of the weather condition. So that means we have three distinct values, overcast, rainy and sunny. So these three values we will check against the yes and no category as per the data set. So let us again go back to this. So we can see here overcast and yes combination. How many records are there? 1, 2, 3, 4 and 5. So these 5 records are present which is having overcast condition as well as yes category. That's why inside this we have overcast, and for yes category we have 5 and we have nil records for overcast and no. Now next comes rainy and sunny. So similarly we are going to calculate the values and place it over here, and this is my frequency distribution table. Also, as you can see, their total number of yes records are 10, which is 5 plus 2 plus 3 gives you 10, and you have 2 plus 2, which is 4. This falls under the no category. Now we will check the likelihood table. So here we are going to see, okay, these are the values which we have already got in the previous slide, but now we need to check the probability, right? So for that we need to check for the overcast condition how many records? 0 plus 5, and you have entire data set, you have 14 records. So 5 by 14 which gives you 0.35, and for the rainy you will be adding 2 plus 2 which gives you 4 by 14 which gives 0.29, as well as for sunny same case you will be doing 2 plus 3 which gives you 5 by 14, you have this particular value 0.35. Again for the entire no class and the yes class you are considering this 2 plus 2 4 divided by 14 which gives you the 0.29, and here it is 10 records which falls under yes category, so 10 by 14 gives you 0.71. So all these values will be required later on when we will be applying the Bayes theorem. So the next slide, as you can see, we are checking, okay, my probability of the player, whether the player will be playing or not on a sunny day. That is my main motto. So for that we have either two classes, yes or no. So for the yes we will be checking, and for the condition which is sunny. So let us see for the yes category and for the sunny condition whether what is the probability value. So for that we are going to multiply using the Bayes theorem which we saw earlier. So P of sunny given yes multiplied by P of yes and then divided by P of sunny. P is nothing but probability, right? So we will be calculating these values. Already we have calculated. So simply you are going to replace these values and you will get a value of 0.60 in this case. Similarly, you are going to calculate for probability of no for a sunny day. So that will give you a value of 0.41. Similarly, you are going to calculate. So now you can see that from the above two values, you can compare and see that 0.60 is greater than 0.41, meaning the probability of a player playing, meaning yes category. So P of yes given sunny is greater than P of no given sunny. So hence we can conclude that on a sunny day the player can play the game. So let us take one more small example. Here the number of attributes are more. Last problem statement we saw only for the weather condition, the outlook. There was only a single column. Now we are going to check more number of features. Let us assume those are like color, legs, height and smelling. And as you can see, this is the species which is my target column. So depending on these values of the features, we are going to predict, okay, for a test instance whether that will be falling under species M or species H. As here also we can see only distinct two values are present inside the species column. So as you can see, my target column is having two distinct values M and H. So those have been placed here, and the attributes are, or the features are color, legs, height and smell. So let us suppose for this test instance, color is green, legs is 2, height is tall and smell is no. I want to calculate, okay, what will be the species. I want to predict that. So for that I need to calculate the prior probabilities. So for the prior probabilities, as you know already, you have total 8 records, right? Starting from 1 and it is ending at 8. And you have 4 values which falls under M class and 4 values which falls under H species, right? So there are two classes M and H. So your probability will be simple, 4 by 8 which is 0.5 and 4 by 8 for the other as well, which is 0.5. Now similarly we will try to consider the each of the features, right? We had color, legs, height and smell. We have the features. So for those features and for the target outcome M and H, I will be calculating, okay, how many are there for that combination, and accordingly I have placed all these values. Now we have to calculate, okay, whether it falls under species M or H. So for that, I will be directly now applying the Bayes theorem. So here, as you can see, I am trying to calculate first for the species M. So P of M given the new instance. So my new instance is nothing but all these attributes, right? I have these combinations: color green, legs 2, height tall, and smelly nose. So I will be placing all these values here. So color is green, given M, because I want to find whether that species belongs to M or not. So right, so given M will come here. Similarly, I will be multiplying for the other one, like legs equal to 2, given M, multiplied by P of height equal to tall, given M, and also I have smelly no, given M. And then ultimately we will have to multiply with that with the probability of M. Since the denominator part is constant, we can simply omit that part for the calculation to make the calculation shorter. So I am just considering the numerator part, right? So after you replace all these values, you will get a value like 0.004 approximately. Same way I will be calculating for the P of H, the other species, and for the new instance category. So like I will be calculating P of color green given H multiplied by P of legs equal to 2 given H multiplied by P of H equal to tall given H multiplied by P of smelly is equal to no given H multiplied by probability of H. Only the numerator part I am considering, and then we are getting a value of 0.047 approximately. So it is clear from the calculations that P of H given the new instance is greater than P of M given the new instance. Hence, we can simply conclude my new species will belong to class A. I hope you are understood the concept and how to solve the numericals as well. So next slide is focusing on the advantages and the disadvantages of naive-Bayes. Advantages of naive-Bayes classification. Naive-Bayes is one of the fast and easy ML algorithms. Since it is only based on the probability, so the calculations done are more efficient and more fast. So it is very fast and easy way to predict whether the how to predict that part becomes very easy. Now it can be also used for binary as well as multi-class classification. It performs well in multi-class classification predictions as compared to any other algorithms, and it is one of the popular choice for the text classification problems. Now coming to the disadvantages. So naive-Bayes assumes that all the features are independent of each other. That's what we had assumed at the very beginning. But we actually in real life data set it cannot be the case. Sometimes there might be dependencies also present within the features. So this is kind of a disadvantage. Now also we can see that if a test data set has a categorical variable of a category that was not present in the training data set, fine. So in that case what will happen? The entire probability of that particular record will come to 0, which should not be the case, and ultimately it will be not able to make any predictions. That means probability becomes 0 means you are not able to decide, okay, it falls under which category or not, or prediction will not be correct. So that is also a drawback of the naive-Bayes classifier. So that's it for today's class. Thank you.